Thank you. Yeah, so my name is Whitney, and like Matt said, I'm a PhD student at UPC. And so I'm gonna talk about kind of practical things in terms of inverting, processing, visualizing magnetotelluric data. I want to just kind of briefly start with kind of who am I, and again I do solve geophysical problems, and I guess kind of what is more important is in this crowd is why do I use Python, and the reason for that is it's awesome. I started using Python about 2.5 years ago because I had been using MATLAB up to that point to do most of my kind of stuff, which mostly involves kind of dealing with data files, dealing with text files, and to be honest, MATLAB is not really good for that. And the other reason was that I was no longer associated with a place that had a MATLAB license, and I was not willing to take that upon me. So Python had been kind of lurking on my periphery for a while, so I just bit the bullet and just dove into it, and within, I don't know, 2 weeks, I was probably better at Python than I was at MATLAB. So, and I guess what is probably more interesting is kind of, I want to show how I have been using Python to kind of just go through these tasks. I mean, I'm not a programmer. I am a geophysicist that programs. I just want to make that distinction. I've been, being here at SciPy, I've been kind of picking up on a lot of proper programming practices that I definitely don't employ. So I think one thing that I'm really looking forward to is kind of trying to take some of that and actually integrate it into what I'm doing. And that's kind of part of what I'm going to be showing you. So just kind of a very general overview of what magnetotellurics are. So like if you saw Lindsay's talk earlier, geophysics are essentially, we have some sort of a source, it interacts with the subsurface, and we get a signal that we measure. In the magnetotelluric case, we have a natural field. So we have lightnings and the auroras that give us an electrical magnetic signal that then amazingly just goes into the ground and interacts with the electric conductivity of the subsurface, and especially with the contrast. So if you have sharp contrasts, makes a secondary field that we then measure on the surface by laying out all kinds of wires and putting up all kinds of coils and stuff. We get out this data files, which are time series, we process them, and we get our impedance data, which is basically a tensor of complex numbers that we then interpret. And just kind of in the corner there, it just briefly to kind of illustrate the fact that the wavelength of the electromagnetic wave will dictate how far they go into the ground. So we actually have some control on how deep we're sensing. So just to kind of put it into some sort of a perspective, a general geophysical workflow consists of kind of 4 modules or 4 tasks. Collecting the data, I mean, going to the field and actually putting the instruments up and getting the data is kind of the first step. Processing data, I mean, you measure something, you get something out of the instrument, and then kind of a suite of things need to be done before you can actually interpret or process it further. The most intuitive way to actually extract the information out of the data that we collect is to model it and invert it. So actually take the data and try to figure out what kind of physical property contrast we have below that kind of would give a rise to it. And then last and not least, assessing the result. Like, there's no point making a really pretty model if it does not make sense in terms of what you're actually trying to look for. So kind of the goal of my work in the last couple of months is to kind of integrate these kind of 3 last steps, processing, modeling, and assessment, into a framework, kind of where it's a single platform where you kind of are not relying on different types of or multiple software to kind of get your job done. Have it easily accessible, interactable, and integratable, and yeah, obviously having interactive capabilities, visual capabilities, and last but not least, have it repeatable. So being able to script something instead of going in and having to click all the correct buttons and set all the right. So just being able to have a script that you just copy, you kind of make minor changes and run it, and because in general we're using similar workflows for our data. So I've been fortunate enough to be working with Lindsay and Rowan on the Simpack, which is a framework for geophysical work aimed for inversion. So the main goal of the framework is to kind of give a platform for inverting data. But that's not necessarily the sole purpose, but that's the main goal. So it's kind of like Lindsay like Lindsay said, it's modularized. So it gives us a very good kind of visual of how we analytically think about our problem towards kind of how we actually program it. So kind of trying to join that language in a little bit simpler, or shorten the path between those two. So without going into necessarily all the details, but it's kind of builds on these kind of elements that I showed earlier. So the Simpack MT is kind of an implementation of the Simpack framework, and kind of the first step obviously is the I/O, importing the data and kind of dealing with it. In the MT world, there are some pseudo-standardized file formats, so having that seem to change between people. I mean, I even produce different kinds of EDI files. So having kind of some capability of dealing with stuff like that and being able to kind of interactively change things that you kind of need to be able to work with the data is important. And having kind of capabilities of doing some minor processing and for us, estimating uncertainties for the inversion is really important part of the work. And to be able to do that, viewing data is obviously kind of preferred. So I'm just going to show a quick notebook. So I just start by importing both the Simpack MT and the Simpack package, though I actually don't use the Simpack. Anyway, but so just to kind of give you an idea of what the file format is, it's a legacy format. It's a text file and has these kind of headers, and then the information kind of in the blocks below the headers. So included in Simpack MT now is a util, which ironically is called EDI importer. So just by kind of telling, by just making a list of all the files that I want imported, giving it into the importer, and then just importing, I now have access to all the data that I asked it to import. So that kind of allows me to take the next step and actually, kind of start working with it and move along in my workflow. And then kind of the implementation part of things is done in Simpack or done with Simpack. And having the capability of forward modeling and inverting is kind of needed, but it's all kind of centralized on the inversion procedure. Built into the Simpack packets, all these kind of modules are included and are easily interactable. And the neat thing about the framework is that in order to get, for example, my MT method to work within the framework, the only real work that I need to do is within the kind of the forward modeling part of it. I need to define the physics, I need to define kind of how the survey works. But then, because we inherit from the same base structure and it's kind of forced to have a very similar namespace, everything else just kind of goes without any kind of major issues. So let me just show you a quick example. Currently, the 1D inversion is working. Okay. Anyway. I have no idea what is happening here. Sorry? Yeah, it's somewhere. Anyway, it doesn't want to bring it up. So we're not going to look at the code. Just kind of move along into the second part. So in the code, you can easily execute, kind of the inversion. You can deal with some of the kind of the settings, the nitty-gritty details that you want to work on, and kind of without having to redefine everything, you can interactively kind of run through and iterate, which is a very neat feature. So the visualization part, I've primarily been using ParaView. So within kind of the framework, there's built-in outputting for the models into ParaView or into VTK format. And then you can kind of load it into ParaView and interact with it. Again, show so this is an example. Make it a little bit bigger. Of some of kind of the work I've been doing. So just modeling. These are 3D models for a geothermal system. And these are just run. It's the same data, it's the same area, it's the same mess, but I've been playing with some of the inputs. And kind of the neat thing that you're able to do here is kind of in the slicing, you can set it up so it's all interactive. I'm looking at the same slice. This is a topographic map of the area that I'm working in. And you can kind of drag and interactively update everything. So it makes kind of visualizing comparisons just so much easier compared to some of the things that I was doing before, like having multiple PNGs open at the same time. I mean, there's no comparison. Yeah, so kind of the way forward is to just continuing implementing the Simpack MT. I mean, there's a lot of features to add. There's a lot of math to go through, and yeah, I mean, most of my work I've been doing in the last 3 months, so it's a very, very, very young package. So there's a lot of optimization and profiling and making things run better and faster that needs to be done. And obviously cleaning and benchmarking. I mean, the end goal is to kind of add it into a packageable kind of state. Then integrating with other packages, move everything kind of more into Python, have kind of command line visualization in 3D, and then leveraging with other packages like VisPy and having HTML5 support. And to be honest, I love working with Python and coming here. This is my first time at SciPy, and just continue enjoying the great open source community that Python provides, and just, yeah, enjoy. Thank you very much. Yes.
I'm familiar with the theory around Simpack in terms of the inversion flavors, or in the linear inversion, linear, probabilistic. What is the state of the art of Simpack?
So, I mean, as it's built, you have options. I mean, I've mainly been using inexact Gauss-Newton for my things that I've been running. There are some other packages, and kind of the beauty about it is that it's easily extendable. And once you have extended it, I mean, it will apply to any of the sub packages. So, yeah, I'm not entirely sure exactly which inversion kind of methodologies are implemented at the moment, but I know Gauss-Newton and inexact Gauss-Newton are, because that's what I've been using.
And also to show other results of your inversion.
Those are kind of older inversions, not run with. I'm not quite up to the 3D inversions in Simpack yet. But yeah, the 1D is working. It's beyond me why it doesn't open, but it wasn't that bad. Any other questions?
All right, well, thank you again.
Thanks.